Okay, so I wanted you all to go ahead and fill in your angles. So I hope you did that. Double check yourself and me. All right, and then if you are going to use the hand trick to find the sine of an angle, what do? Good. What about cosine? What about tangent? Good job. All right, and then there are going to be some situations where you have to use the unit circle. You can't just do the hand trick. And so on those, you would go ahead and draw a XY axis and label the quadrant angles on it, please. And each one of these points is technically on the unit circle, even if we don't draw the circle, and they're all 1 unit away. So I'm just going to label them like they're 1 unit away. So if you're on the unit circle and you want to find the sine, what do you do? What do you use? The y. Good. And then the cosine, we're just going to use the x. And then the tangent, we're going to do y over x. All right. And then we're also going to need to know the acronym to determine where each trig ratio is positive. What is that? Good. All students take calculus. And then what we're doing today is different than what we did yesterday. So yesterday, if you are given the inverse trig function, it's very, very restricted what angles you can give as your answers. Today, we're given any angle that works that's between 0 and 2 pi. So it's going to be different, so don't get frustrated or try not to get too frustrated. So we are going to also draw the angles in the other quadrant. So the angles that are on the hand trick, these 3 in the middle, you're going to want to know what they are in the other quadrants. So I'm going to draw one for each of those. I saw somebody did one drawing for all of them, and you can do that if you want to. It doesn't make you too confused. I like to separate them, but everybody do what you need. This is going to be the one for pi over 6. Keelan, if you want to turn around, you can turn the desk around. It's going to be annoying, so do it that way. All right. Do you guys know what pi over 6 is in quadrant 2? Pi over 6. So it's pi over 6 less than pi. So that's 5 pi over 6. This one is pi over 6 more than pi. 7 pi over 6. And this last one is pi over 6 less than 2 pi. Very good. To me, that's the most difficult one to remember. The next one is the easy that I'm going to do. I think it's the easiest one to remember. So we'll do the same thing for pi over 2. No, just kidding. Pi over 4. All right, so when we're doing pi over 2 around the quadrants, you're just going to the next odd number. Okay. And then we have one more that we're going to do for pi over 3. On pi over 3, you're basically adding a third each time. So then it would be 2 pi over 3. 3 pi over 3 is pi. And then 4 pi over 3. Maybe. and then 5 pi over 3. Okay, so all of these things you need to know to do what we're doing today. So being able to do the hand trick, and then knowing the unit circle and all the special angles in the other quadrants. So we're going to practice it. I'm planning on doing a test on this on Friday, which will be a full week from when we did this the first time. So I think this is something you can learn in a week. But we're going to practice it every day until the test. All right. So there is a typo on this. On example 1, we shouldn't have this or equal to on the 2 pi side. So we are finding all the angles between 0 and 2 pi, but not include 2 pi. So this is different from before, when it was only certain angles that you could give as an answer. We're going to give all the angles that we just wrote, basically, that work for this situation. Now, one thing that's different from when we did this before, when we first learned the hand trick, is sometimes we're going to need to isolate the radical. Wrote too big. Not radical, sorry. Isolate the trig ratio first. So if there's something that is being multiplied by it, or something that is added to it or subtracted from it, move that to the other side first, and then we'll figure it out using the hand trick or the unit circle. Bless you. All right, so what would you guys do on example 1a? Divide by 2. So first thing we want to do is get rid of the 2 that's being multiplied by the sign. So it's going to be sine of theta is equal to negative square root of 2 over 2. All right, so we wrote down a minute ago that to find the sign using the hand trick, it's the square root of the bottom over 2. So that means we want 2 bottom fingers. That's pi over 4. Is the sign of pi over 4 negative square root of 2 over 2? No. So pi over 4 is like our reference angle. So it's going to be some of these. All right, and then for you to take the sign and get a negative, it is in quadrant 3 and 4. I don't know why. There we go. All right, so you go up to what we just wrote for pi over 4, and we pick out the angles that are in quadrants 3 and 4. Those are all the angles between 0 and 2 pi that I can put into this theta, and it gives me a true statement. All right, we're going to do one more, and then we're going to run out of time. So this one, we have the cosine of theta equals 1. Well, the trig ratio is already isolated, so we don't have to do anything with that. Do you guys remember on Friday what I told you to do if it was the cosine of theta equals 1? Unit circle. So we're going to rewrite that down. So if it's sine or cosine of an angle equals 1, negative 1, or 0, you're going to go to the unit circle. Okay. So on our unit circle, to find the cosine, we'll use the x-coordinate. So for our equation, the cosine of theta equals 1, we want the x-coordinate to be 1. So what do y'all think? 0. The angle is 0. 0 radians. And that's it.